to Drakey's channel. So today's experiment is ipapakita namin ang different properties of proteins. So hi guys, I'm back. So ngayon kasama ko na si Sir Jello. So nag-prepare na siya para sa gagawin naming live demo. So yan. So pag nag-live demo kami guys, is triple gadget yung gamit namin. Si Sir Jello is gumagamit siya ng tab, laptop, tsaka ito external monitor. Kasi dito makikita namin lahat ng mga participants, yung mga students na kasama sa klase kasi tatlong classes sila, 3 classes, three sections yung kasama sa live demo. So yung mga students ni Sir Jello, ni Ma'am Ador, hindi pala guys, parang dalawa lang ata kasi Sir Clyde, mamaya pang hapon yung klase niya. So hindi ako sure kung 2 or 3 ganyan. So dito makikita namin lahat. So yung sa camera nila is para makita namin yung students, ang gamit na is Zoom. Pag pag sa lecture naman dito, bongo, yung sa ang ginagamit ng CDU na para sa online classes. So ayan guys, balik ko kayo mamaya.
Clearly. Okay, so good morning. I will be recording this for the benefit of those who will be able to come today. Okay, so kindly turn on your cameras and Zoom now. So again, class, the instruction is you're going to watch the live demo in this platform, in Bongo. So in Zoom, it shall be your second device, okay? So we are joined again, section C and section G, together for this live demonstration. So what we will be doing is the first part of ABCL number 5, diba? We've already uploaded the laboratory guide in your cello, right? Can you see it now, class? No? Have you seen your lab guide already for experiment number 5? So it's the first part of the experiment that we will do. Specifically, we will do denaturation of proteins. Okay? Sige. So before I'll start the experiment today, I would like to give a short background of what really is denaturation. Okay, supposing for example, in your screen right now, I am actually projecting a question that says, why does egg white turns from clear to opaque after boiling in water? Diba? So have you wondered before? How come, diba, ang egg white, if it's not yet cooked, it's transparent. However, once it's already placed in a boiling water, it's slowly becoming white. So why is that? So that is due to the fact that the proteins in the egg white undergo a specific change. The specific change in the structure of your egg white is known as denaturation. So when we say denaturation, class, if you remembered, a protein is actually containing a 3-dimensional structure. So when we say denaturation, it is simply changing or disrupting the 3-dimensional structure. Kaya naka-fold man na ang atong protein. So when you unfold the structure of your protein, that is what we call denaturation. And always remember, class, the 3-dimensional structure of your protein is very much related to its function. So in other words, when we denature our protein, we will actually be losing its function as well. Okay? So is that clear to you? That is what we're going to demonstrate today. What are the different factors that can actually denature your protein, or in other words, what factors can destroy the integrity of the 3-dimensional structure of your protein? Is that clear? Is that clear? Okay? Sige. Can you hear me? I can see no responses from the crowd. Did you get what I'm trying to emphasize? Okay? Sige. So yeah, that's the background, no? So we're actually showing you today denaturation. So you may now, maximize the camera. Present in your, what specific portion of the egg contains albumin? What specific portion of the egg class? Is it the yolk or the egg white? Kinsa may na ay egg? Okay. It's the egg white that contains the egg albumin. Okay? O may pang mga taga section G, no? Kay kusog kay mo participate. Ang ako ang section, kay asa na ni? Gibutang sa Ginoo. No? So, this is the protein we're gonna use today. And we're going to react it with different chemicals and with different conditions in order to see what will happen when egg albumin will start to denature. Again, what is denaturation? Denaturation is simply the disruption of the three-dimensional structure of your egg albumin. So let's start with the first factor that can denature. We will have your heat. Okay? So I have here my, do you remember what is this? This is your Bunsen burner. No, this is the source of heat in the laboratory. So I will light this up first. So let's try to see what is the effect of heat in your, the effect of heat in your egg albumin. Okay, so let me light. Let me adjust the flame first. Okay, so we have now a fairly blue flame, no? So this is the flame that we will be using for heating. Okay, so as you could see, so I will now place 1 ml of my egg albumin in the test tube. Okay, so this is my egg albumin. I'll place 1 ml. Okay. Right. So let's try to see what happens to my egg albumin when I heat this in the Bunsen flame. Okay? So let me heat this like this. Again, heating of a fluid is always done at a angle 45 degrees, and then you heat not at the bottom but at the ari ka magsugod no sa surface sa liquid. Okay? And you do it this way. Okay, so it's already done. Okay, try to look at now what happened to the albumin upon heating. What did you notice? Okay, let's try to compare it before heating, ha? Okay, para makita ninyo. Diba, before heating, it's actually liquid, right? Am I right? But what happens after heating, class? It actually solidifies, it clumps, no? It clumps together. So this clumping is what we call coagulation. Okay? This clumping is called coagulation. As you could see there, the particles of your egg albumin clump together, no? So they clump together, class, no? They clump together, forming a huge chunk of solid, right? So that is what we call coagulation. Mura siya ni solidify ba into large chunk, no? So that's coagulation. So what's the effect of heat when you try to heat your albumin? It actually is coagulates, no? It coagulates your protein. So heating, therefore, coagulates your protein. What do we mean by coagulation? the solid will clump together to form a very, very clumpy substance. Do you follow? So the clump that we see is actually what we call your coagulum. Is that clear? Is that clear? Okay, so heating coagulates protein. Okay? Let's now try other factors. Let's try your... Okay, so I still have here my egg albumin. So let's try mixing it with alcohol. By the way, have you recording your observations in your lab manual? Did you record your observations in the lab manual, ladies and gentlemen? I hope you're doing that, ha? Sige. So let's now try albumin with 95% ethyl alcohol. So what I'm going to do here, I'm gonna add equal volume of my alcohol into my egg albumin. Let's try. What will happen? Okay. So what did you notice, class? Upon the addition of ethanol, how would you compare it with this? Do they have the same structure? Do they have the same product? Do they, both of them, what do they form? Did they form precipitate or coagulum? Diba? Okay. Both heating and adding alcohol actually coagulated your egg albumin, right? Diba? So therefore, heating and alcohol can coagulate your egg albumin or your other proteins. That is why, class, when you disinfect your hands, what do you use to disinfect your hands? You use alcohol, correct? So what is the use of alcohol? Why do we use alcohol as a disinfectant? Because it can coagulate the proteins in the bacteria, in the microorganism. So that's why it can potentially kill your microorganism. It can coagulate the protein in the bacteria, man. Do you follow? And what is the What is the prescribed percentage of alcohol na effective for disinfection sa hands? It's your, ano sa man nga percent? 70%. Okay, very good, Miss Gordon. Okay, so in reality, class, if we're going to look at it, kung imong i-compare ang effect ni 70% o ni 40%, no? Makapatay naman sila both sa bacteria. But why do we use 70%? The reason for that is, diba, if for example, like a wound, you have a wound here. So if you place a very, very high concentration of alcohol, let's say, I add 95% of alcohol to my wound. What happened? The skin surface in my wound, because it contains protein, it will coagulate. So it will prevent the alcohol from entering the wound, sa internal sa wound. So, ang katong naa sa ilawom sa imong wound, kay dili ma-disinfect. Am I right? Whereas, if I use 70% of alcohol, what happens? There's still water, right? So, dili niya ma-coagulate ang surface sa wound. So, it can penetrate into the wound and disinfect even the internal of the wound. Do you follow? Kaya imagine, 95%? This is what happens to protein when you mix, when you add 95% of alcohol. No? It will harden. So, maunang, it can harden the tissue of your skin once you place very concentrated alcohol. Do you follow? Do you follow? Okay? Sige. So now, let's try another types, no? So, let's try precipitation of your albumin. Okay? So again, we'll be adding again, no, albumin here. So for this point, so timan ito ninyo class, no? You remember that, no? Heat and alcohol can coagulate your protein. Now let's try heavy metals. No? So I have here my copper in the form of copper sulfate. So this is a heavy metal. And then I have here my silver in the form of silver nitrate. So these are metal salts. And I have here my lead. No? Lead in the form of lead acetate. And then lastly, I have here my very, very toxic, no? Very toxic mercury. So careful, taning mercury ha? Okay, very toxic. So what we're gonna do is, we're gonna add 1 ml of this heavy metal into test tubes containing albumin. Okay? Sige. Sige. Let's start with, as you could see in the label, let's start adding lead acetate in this test tube. Okay? So, this is my lead acetate. Okay, so let's try to see what is the effect of adding lead into my egg albumin. Okay. What did you notice, class, upon adding lead to my egg albumin? Compare it when you added the alcohol. Compare it. How do they differ from each other? Is it the same? As you could see, these clump together, right? This clump together to form a very big solid, no? But in the case of your lead, try to look at it. Wala man siya ni clump, no? Ni-separate ang solid, no? Some of the solids separated, which means to say that there is the formation of your precipitate. Do you follow? There is the formation of a precipitate because if it's coagulum, the entire solution will be converted into a solid, white solid chunk. Do you follow? In this case, ni-separate ang ato ang solid, which indicates that the solid that was produced here is basically a precipitate. So how do you characterize the color of the precipitate that was produced by adding lead acetate? Okay, so Lance here, Lance Salota already said, this is basically a white precipitate. So lead acetate plus albumin produces white precipitate. Is that clear? Is that clear? Let's try the other heavy metals. Let's try let's try now your copper sulfate. Okay, let's try copper sulfate. What's the color of copper sulfate, class? This is blue. Okay, let's try. So what will happen to my albumin when I add copper sulfate? So what did you notice? Diba? As you could see, do we have a white So, white background. So as you could see there, what did you notice? Diba? There are also solids that separated, right? No? Can you see it? There are also solids that separated from the solution. So meaning to say, is this coagulation or precipitation? This is also precipitation. And what is the color of the precipitate? The color is blue. Diba? So nakita ninyo, no? Okay. Because the same ragud, no? Aklas, no? Ang effect ni lead, no? The same ragud ang effect ni lead o ni copper. Nga naman. Because both of them are no? Both of them are actually heavy metals. So you would expect them to have the same effect. Okay? So for copper, for lead, it's white. For copper, it's actually somewhat it has blue tint to it, sometimes green, bluish green. No? That's actually correct. Okay? Very good. So let's now try your silver nitrate. Okay? So this one contains a label silver nitrate. So we'll add now your silver nitrate solution. Okay? Let's try to see what is the effect as well. So what do you predict? What do you predict is the effect? Is this precipitation or coagulation? What do you think? This will be... Okay, this will be precipitation. Okay, let's try to see if it's really precipitate. Okay. So try to look at there. Diba? As you could see, there are solids that separated from the solution. Am I right? No? There are solids that separated from the solution, meaning to say it's a precipitate. How do you characterize the color of silver nitrate precipitate with protein? That's actually white. Okay, white precipitate. Okay, very good. And the last heavy metal we're gonna use is your... What's the last heavy metal? We will use your mercury, no? Agoy, sao na lang. No, so mabaog lagi ko ani, dinadyo ko anak kasi sige ko higop direct mercury. No, sao na lang. Wala jud ko ani anak. Nakatawa sila, no? So ano, di mo mo totoo. Sige. So let's try adding mercury into my egg albumin. Hala, nangatawa sila, ma'am. Okay, so what did you notice as well? Diba? There are also precipitate that is actually forming. Correct? No? So this is also precipitation. What's the color? The color is white. Okay? So these are now the results of your heavy metals. So as you could see, heavy metals precipitate your proteins. Okay? They precipitate your protein. So only copper has a differently colored precipitate. Okay? So, unsa may significance ani class, no? Unsa may significance aning fact nga ma-precipitate ni heavy metal sa protein. For example, na kay mercury nga thermometer, no? Giinom nimo kay ano, curious kayo ka, di ba? Of course, mercury is actually poisonous. So, what is your antidote to mercury poisoning? It's actually egg white, di ba? You actually drink egg white immediately. Why? Because the mercury that you ingested will be precipitated by the egg white that you drink. And then afterwards, you induce vomiting so that the precipitate that was formed can be vomited and can get out from your system, no? Including the heavy metal that was precipitated by the mercury. That was precipitated by the egg white. Do you follow? Do you follow? So mauna nga ginagamit si protein as antidote for metal poisoning to remove, no, to coagulate or to precipitate the heavy metal that you ingested, no? That's the significance there. All right? Question so far. So what did we see already, no? So we saw that your protein is it coagulated or precipitated by heat? It's coagulated, right? And then, how about your alcohol? Can it coagulate or can it precipitate? Okay, it can also coagulate. Okay? And then your heavy metals can precipitate. Okay, very good. So now, let's try the effect of your strong mineral acids. Okay? So for strong mineral acids, we have, first we will use your concentrated nitric acid. What do you call the test that uses strong mineral acid as nitric acid? What test utilizes nitric acid? Ano sa mga test? Strong nitric acid. You have your, ano sa man? No, katong mo form o white ring. Naman siya yung video, di ba? So you have your Heller's test, no? The white ring test, okay? Sige. So I'll add albumin here, ha? Again. So, diba? Nakoy albumin. So how do I do the Heller's test? I actually do it this way, no? So I tilt it at 45 degrees Celsius, and then I run down my nitric acid at the side. Okay? So you will see that there is actually the formation. Dili ka siya apparent, no? Let us try it again. Kaya di ko ganahan, maulawan ko. So let me try it again. Kaya dili kay maklaro ang imuhang kuan, white ring. Kaya si Heller's mo, use mo guna siya for kanang low concentration of proteins, ma'am, no? Okay, highly concentrated mo kayo. Okay? So there's the, so it's not a ring actually. So it's not a ring, as you could see, it's a white stain. It's a white stain, no? Okay, what's the form of ring? But nonetheless, what did you notice? Upon the addition of the nitric acid, what was formed? It formed a white substance, a white precipitate. Do you follow? That's the effect of your Heller's test or Heller's ring. Do you follow? So if you're going to ask me, sir, why weren't you able to form a Heller ring? The reason for this class, this is basically pure albumin. Do you follow? So you would expect it to have a lot of protein. So normally, Heller's test is used in urine, di ba? If your urine contains small amount of protein, of course, that's the time that you will expect it to have a white ring. But in this case, because it's a concentrated protein, Aleja, yes? Do you have concerns? Aleja? Wala. Nasayo pa na siya. Anyway, so again, just like what was I explaining earlier, so it's actually a white ring supposedly. And this is also precipitation. Do you follow? But class, take note. When you stand this over time, it will slowly turn yellow. Okay? It will slowly turn yellow. But the yellow coloration is not the positive test of your Heller's test. Do you follow? It's actually the white ring. So let's now try your Robert's test. Okay? Let's try your Robert's test. So I have here now my Robert's reagent. Natin water, Ma'am Lala.
Distilled water?
Oh. For a while, let me first ako sa siyang try of dilute kay marag concentrated kay atong solution. Ay sakto man for urban test. Okay. Sige. Okay. So as you could see there, diba? There is the production of what? What is that? What did you see? Upon the addition of the Robert's reagent, there's also the formation of a white ring, correct? Or white precipitate, but that's supposedly a ring. Okay? Always remember, class, for Heller's and for Robert's test, you are supposed to produce a white ring. Okay? So in this case, it actually formed a very, very high concentration of precipitate due to the fact that we're using pure albumin. Okay? We're using pure albumin. That's why nga it turned like that. Alright. So therefore, what is the effect of your mineral acids, class? What's the effect of your mineral acids? They're able to produce rings. So what is the ring? Is it a precipitate or a coagulum? It's a precipitate. Do you follow? Precipitate. The formation of the ring is actually an indication that it's a precipitate. Okay? So lastly, our last experiment would be using your, what are these reagent? Your tannic and picric. How do you call this reagent? You call them these are your alkaloidal reagent. Okay? So these are alkaloidal reagents. So by the way, class, their structure is, they have, what's the charge of alkaloidal reagents? They usually have positive or negative charge? Okay. They usually have negative charges, no? Your alkaloidal reagents, okay? Sige, so they are anionic, okay? So let's now try to see what will happen to our protein when we add alkaloidal reagent. Okay, sige. Let's first begin with your picric acid. So the picric acid is the yellow liquid. Okay? Let's try to add picric acid now. So what did you notice? Upon the addition of picric acid, there are yellow precipitate that produce. Right? Sige. So try to look at it, class, when I add excess of the reagent. What happens when I add excess? What happens to the precipitate when I add more of the reagent? Did it increase or did it decrease? Okay. So this is now the effect of your alkaloidal reagent. Okay, always remember this, ha? Even in excess, your alkaloidal reagent would still precipitate your protein. Always remember that. That is different when we say acid. Okay, timani ha? When it's acid, when we add excess reagent, the precipitate will dissolve. But once it's alkaloidal reagent, even if I add excess of the reagent, you would notice that it will increase in precipitate. Do you follow? Do you follow? So that's the difference between alkaloidal reagent and mineral acid. Because alkaloidal reagent in excess will increase the precipitate. But mineral acid in excess will dissolve the precipitate. Let's try tannic acid. Where can we find tannic acid, class? Where can we find tannic acid? It's in your teas, no? Tea, no? Tannic acid, tea is very rich in tannic acid. And this is also used to dye. This is used as a dye, okay? As a colorant agent ba? So let's try to see now if we add tannic acid. So initially, we produce what precipitate? What's the color of the precipitate that we produce? Brownish, correct? Brownish precipitate. So what if I add an excess of my tannic acid? What do you expect if I add excess? Will it dissolve the precipitate or will it increase the precipitate? Increase, because this is an alkaloidal reagent. Do you follow? Do you follow? O, sige kasi, dinaghan siya. So, sige ko butang. Am I right? Because this is an alkaloidal reagent. Okay? So, these are now the effects of your alkaloidal reagent. So, there's plenty of precipitate that we produce when we add excess of your reagent. Okay. So these are now your denaturation of proteins. So as you could see, there are two types of denaturation. What are the two types of denaturation again? We have your precipitation and coagulation. Okay? So what can cause coagulation, class? Coagulation is caused by your Okay, heat and alcohol. Para murag plusan guni ni Ma'am Ador si Crystalline. Okay, oh, gabi siya ka participative. Okay? Sige, then what causes precipitation? You have your heavy metals, and then, ano sa pa? Okay, si Lance, si Lance for Ma'am Ador ha, plus po ni siya. No? So you have your heavy metals, you have your acid, and your alkaloidal reagent. Okay? So, unsay difference class kung coagulation? They will form a clump, no? They will clump, no? They will clump, right? But kung precipitate kay mo separate sa solution. Do you follow? Do you follow? Okay. Sige, question so far. Questions? Wala na? So if you have no more questions, then that would be all for now. So I hope you've learned something today.